In this video we're going to carry on talking about simultaneous equations. However, we are going to solve it not graphically but algebraically using something called the method of substitution. Well, what does that mean? It means that we have two equations and we have two variables. From one of our equations we are going to solve for one of the variables, substitute it, which means put it into the other equation, and then solve that equation, and then use the result of that solution to solve for the other variable. Sounds complicated, I know, but if you hang with me, it's going to be fine. Let's take a new slide. So let's just write down the recipe, if you like. So we have to, step one, solve one equation for one of the variables, substitute this variable in the other equation, and solve for the other variable. And then finally use this solution in the first equation. Let's take an example. So we have to solve the set of simultaneous equations y equals 3x minus 2, y equals 4 minus 2x. And the curly brackets to show that there are a set of simultaneous equations. And then sometimes you'll see after the equation brackets 1, brackets 2. This means equation 1, this means equation 2. So we have to solve this using substitution. Now, luckily, in this example, it's quite a simple example, we already have one of our equations in the form y equals, so we don't have to do any rearranging to start with. So we just have to substitute y equals 3x minus 2 from equation 1 into equation 2. So anywhere I see a y in equation 2, I substitute 3x minus 2. So, and luckily in equation 2 I already have a y equals on its own. So I just put, in equation 2, instead of writing y, I write 3x minus 2 from the first equation. 3x minus 2 equals, and then I've still got the right hand side of equation 2, 4 minus 2x. Now you see this equation only has x's in, so I can solve this for x. And I want to move, I have a negative x here, I want to move that to the right hand side and get everything, sorry, on the left hand side. Everything else I want to get on the right hand side. So let's start with moving over the minus 2. Get rid of that by adding 2 on both sides. I have 3x equals 6 minus 2x. To get rid of the minus 2x, I then just add 2x to both sides. So I get 3x plus 2x equals 6. 3x plus 2x is 5x equals 6. So x is 6/5. Or 1.2. So we found x equals 6/5 or 1.2, and then I have to use this result back in the first equation. So substitute x equals 1.2 into equation 1, and I get y equals 3 times 1.2 minus 2, which is 3.6 minus 2, which is 1.6. So the solution of this is x equals 1.2, y equals 1.6. Let's try a slightly slightly more difficult equation. Let's take this one here. Solve the system of simultaneous equations 3y minus 4z . 3y minus 4z equals 17, and y minus 5z equals 2. They've got this curly bracket, so we know they're a set of simultaneous equations. This is we'll call equation 1. This we can call equation 2. Now, it's easiest for me to solve for y in the second equation because I only have to move the minus 5z to the right hand side. So, and we asked to, by the way, we're asked to solve this exactly. That often means you're not allowed to use your calculator, so probably going to end up having an answer in fractions. So solve for y in the second equation. We get y minus 5z equals 2. We have to then add 5z to both sides, which gives me y equals 2 plus 5z. Now, substitute y equals 2 plus 5z in equation 1 gives me 3. Now I've got to put, wherever I see a y, I have to put this 2 plus 5z, but remember to keep it in brackets and then multiply out the brackets later. 3 brackets 2 plus 5z minus 4z equals 17. Then I have to simplify, multiply this into the brackets. I get 3 times 2, which is 6. 3 times 5z is 15z. Minus 4z equals 17. 15z minus 4z is 11z. And 17, move the 6 over here, gives minus 6. 17 minus 6 is 11. So 11z is 11, so z must be 1. That was nice and easy. So now we've got z equals 1. We put that back in this equation here, which was equation 2. So from equation 2, we we now get the solution to y, which is y equals 2 plus 5 times 1, which is 7. So the solution is y equals 7, z equals 1.